Hello everyone, this is Nagalakshmi Devi, Minister of Aeronautical Engineering, Dundigal, Hyderabad. Now complex functions and differentiation. Now the first one is complex functions. Complex number. For a complex number z equal to z plus iy. Z equal to z plus iy. The number of real z equal to x. Real number is z equal to x is called the real part of z. And the number imaginary part is iy. Z equal to iy, the imaginary part is only y. Is said to be its imaginary part. Now y is imaginary part and x is real part. Then if x equal to 0 is said to be a purely imaginary number, then this is purely imaginary number. Now the definition of x equal to z equal to x plus iy. Here it is a real part, and this is imaginary part. The definition of this one, let z equal to x plus iy is belongs to C. C is a complex number. The complex number z equal to x minus iy. Here z equal to, they are given x plus iy and z bar equal to x minus iy. Then is called the complex conjugate of z. And for example, mod z equal to, then we get the x square, then mod z equal to square root of x square plus y square is said to be the absolute value. This is a absolute value. This is a absolute value of the modulus of the complex number z. Here z is the complex number. Here that is z equal to x plus iy. X is a real number and y is the complex number. Now the conjugate complex number mod z equal to square root of x square plus y square is the complex number. Here z is called a modulus of the complex number is z equal to absolute value. Then it is said to be square root of x square plus y square. Then here D is the domain. Now let D be a non-empty set in C. Compulsory here any set is not an empty. Here any number is there, any value, any complex number, it is there, then it is called non-empty set of C. A single valued complex function, simply a complex function. Here we can say it is simple, simply we can say it as single valued complex function, that is f from D to C. Now D is domain and C is complex number. Is a map that assigns to each complex argument, that is z equal to x plus iy. In domain D. In this domain D, we get z equal to x plus iy. In D, in a unique complex number, that is w equal to f of z equal to u plus iv. That is the unique complex number. W equal to u iv, where we can write it as w equal to f of z, u plus iv. If the given function is like this, w equal to x square plus iy square, here u equal to x square and v equal to y square, like this. The set D is called the domain of the function f, and the set of f of D is the range or the image of f. F of D is the range and f is the image of that domain D. So, a complex valued function f of a complex variable z is a rule that assigns to each complex number z. Is said to be in this, it is their domain D, only one complex number, that is w. That w is nothing but u plus iv. We call w is the image of z under f. In says that w is the image of z under the f. Okay, now here z equal to x plus iy is belongs to D, domain D. We shall write it as f of z equal to u of x comma y plus I into v of x comma y, or f of z equal to, we can easily write it as u of z plus I v of z. The real functions u and v are called the real and imaginary values respectively. Real and imaginary part of the functions of f. Therefore, this is real part and v of x is a imaginary part in respectively of z equal to x plus iy. Therefore, we can describe a complex function with the aid of two real functions depending on the two real variables. Here compulsory we are depending upon the two real variables, that is x comma y. Okay, here also that is a two real variables x comma y. In this is a completely it is a real part. This is in complex number it is a real part of this one. For example, cos x plus I sin x. Here sin x is a real number, but it is combination of I that is complex number. Cos x is a real number, real variable. Okay. Now, for example, we can choose this is the function f from s to c to c tends to c defined by f of z equal to z cube or f of z equal to z square. Can be written as f of z equal to u of x comma y plus I into v of x comma y with the u of v is tends to r square tends to r given by u of x comma y equal to x cube minus 3xy square and v of x comma y is equal to 3x square y minus y cube. We can solve this problem now. Okay, now second example also we are writing that one. For the function f from c to c defined by f of z equal to e power z, we have u of x comma y equal to e power x into cos y and v of x comma y equal to e power x into sin y for any x comma y which belongs to R. Now we are solving the first problem is in terms of z square, then after z cube. Okay, now let w equal to f of z equal to z square for all z. Find the value of w which corresponding to the z equal to 2 plus I, that equal to z equal to 1 plus 3i. Now here I am considering the given first problem solution is w equal to f of z equal to z square. Now the first part is z equal to 2 plus I, that implies w equal to f of z equal to f of 2 plus I, that equal to 2 plus I whole square, that implies a square plus b square plus 2ab, that means 4 plus I square plus 2i plus 2 into 2 4i, that equal to 4 I square value is minus 1 plus 4i, total 3 minus 4i. Here 3 is the real part of the given function and 4 is the imaginary part of the given function. And next one is second one is w equal to f of z equal to z square, then z equal to 1 plus 3i, that implies w equal to f of z equal to f of 1 plus 3i, that equal to 1 plus 3i whole square, that means 1 plus 3i whole square, that is 9 into I square plus 3 into 2 6i into 1 it is 1 6, then 1 plus 1 minus 9 I square value is minus 1, that's why it is minus 1 plus 6i, that equal to overall minus 8 plus 6i. Here 8 is the real part and minus 8 is the real part and 6 is the imaginary part of the condition. Now assume that the given function w equal to f of z equal to, that is u plus I v, u equal to x plus I y whole square plus I into next x plus I y whole square, that equal to x square plus I square y square plus 2x, that means 4xy I, that equal to x square plus 4xy I minus I square value is 1, that is y square. Now common with the two terms, that is x square minus y square plus I into 4xy. Here u equal to, here I am substituting f of z value directly, that is x plus iy. Z we know what is z here, z already we know, that is z equal to always x plus iy. Okay, now the given function f of z equal to z square, that's why I am substituting f of z here, that is z square equal to x plus iy whole square What is u here? What is u here? It is x square minus y square. What is v here? 4xy. That's all. Here any value in z, in terms of z, they are given the function is f of z equal to z square. Now the two conditions are satisfied. Which one is real number and which one is imaginary value? Here the substituting of z in terms of z square, we get z square equal to f of z for all z. This is one another one. Now here f of z equal to z square. Now w equal to f of z equal to f of z means 2 plus i. First concept we are considering first part, that is 2 plus i. Now substituting f of 2 plus i, that is 2 plus i whole square. Then substituting expansion, that a plus b whole square, that is 3 minus 4i. Here 3 is the real number and minus 4 is the imaginary number. Which one is real number, which one is imaginary number? They are asking that one corresponding to the first one. Now second one we are substituting same as earlier procedure, that is z equal to 1 plus 3i. Now substituting that one we get minus 8 plus 3i, that is minus 8 is the real number and 6 is the imaginary number. In that condition, now w equal to f of z, that equal to u plus iv we know. What is u, what is v, we are finding here x plus iy whole square, that is x square plus I square y square. Here I square is nothing but minus y. Now real parts are common with one part and imaginary part is another part. This is u and this is v. Now here it is 2 only. Now this is 2 only. Why? Because here they are given only 2 only, na? 2. This is also 2. This is also 2. 2. V equal to 2xy. Now this is the condition. Similarly, in f of z equal to z cube, they are asking in earlier one. We are solving that one in this method. Okay, we can solve that one first of all. That is f of z cube. We are solving here, it is better. F of z equal to z cube. That means z is z value we know. Z equal to x plus iy. Then x plus iy whole cube. That means a plus b whole cube. A plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. That means here it is that equal to x cube plus 3x square iy, p value is iy, that's why 3x iy whole square plus iy whole cube, that equal to x cube plus 3 I into 3x square y plus 3 not this is plus y because I square is there. I square is there, here it is. I square value is minus 1 minus 3x y square plus I square value is minus 1. That's why it is minus. I is there. I cube can be written as I square into I. Then I square value is minus 1 into I. Total this is minus I. That's why I am using here it is minus I y cube. Now what is imaginary values? What is real values? X cube minus 3x y square is the real part and plus imaginary part is I into 3x square y minus y cube. Therefore, here u equal to w equal to u plus iv. Now w equal to f of z, that equal to here u equal to x cube minus 3x y square and v equal to 3x square y minus y cube. Here we can solve that one. Here u of x comma y equal to x cube minus 3x y square and v equal to 3x square y minus y cube. Hence this problem is completed. Similarly, e of z also. E of z means here we are considering, okay, you can remove this one. Now, e of z equal to f of z equal to e of z. Now substituting that one in z, in terms of z means e of z equal to x plus iy. I am substituting that part. W equal to f of z equal to e power z. z equal to x plus iy. Now, continuing this process, we get u of x comma y equal to e power x cos y, and v of x comma y equal to e of x into sin y. Okay, now here it is. Z part completed. Next, what about the second one? In terms of Z1, in terms of next one is W equal to f of z equal to z square plus z. That means x plus iy whole square plus x plus iy. Now x plus iy whole square expansion. Then after adding that one, we get some u and v values. Finally, that is the u and y. And what is the I plus y means? I plus 1 plus I is nothing but I am substituting f of that part is z square plus z in that part. And this one, that one, they are mapping that one. That is x square plus 2iy minus I square value is 1, that is y square plus x plus iy. Now that is in real parts x square minus y square plus x. In imaginary parts plus I into 2y plus y. That is x square minus y square plus x plus I into 3y total. Therefore, here w equal to u plus iv. Here u equal to x square minus y square minus x plus x, and v equal to 3y. And v equal to 3y. What about the next one? What about next one? Here I am considering that part is okay. Here it is 2xy. Here this is 2xy. This is 2x. Not this is 3y. This is 2xy. Now this is 2xy. 2xy plus y only. Now this is also 2xy plus y. Then what about next one? Here it is then f of z equal to, they are asking at a point 1 plus I. I am substituting that in the given condition, that is u equal to f of z equal to f of z is equal to z square plus z. That means 1 plus I whole square plus 1 plus I, that equal to 1. I square value is minus 1 plus 2I plus I plus I 1. Then 1 cancel. 1 plus 2I, that is over 3I. Here W equal to U plus IV. Real part is I 1 and imaginary part is 3. That's all. Now that is the problem. Now next one is solving. For example, here we are considering, for example, this is, for example, they are given f of z equal to z square plus z bar. Otherwise, we are giving the like this means x plus iy whole square plus z bar is z equal to x plus iy. And what about z bar? Z bar is x minus iy. Substituting that one. Okay, x minus iy. Then this is x square minus y square plus 2xyi plus x minus iy. That means x square minus y square plus x plus 2I equal to 2xy minus y. Therefore, u equal to x square minus y square plus x, and v equal to 2xy minus y is the another method. If they are given z bar, compulsory we are substituting x minus iy. In z equal to x plus iy, the conjugate is x bar equal to x minus iy. This is the complete conditions of functions of complex variables. Functions of complex variables. Here z equal to x plus iy and z bar equal to x minus iy. Now that is the conclusion of that one. Functions of complex variables. Now the limits of a function. Then after continuous, then after differentiation. Now if any solution is analytic, then we can solve before limit of a function, continuous of a function, and differentiation of a function. Now the first condition is limits of a function. limits of a function, let D is subset of C, comma, C is a complex number and D is a domain. A belongs to D dash. In codomain is a D dash, and F from here A is in terms of codomain of element, and F from D to C, a number I belongs to C is called the limit of a function F at a point A. If for any value V is belongs to Vi, then it is U belongs to V of A, such that for any of Z belongs to U intersection D, such that the following conditions are limit Z tends to Z naught F of Z, that equal to limit I. L, we are considering capital L, capital I, choice is ours. Now, the remark is, if a complex function f from D to C possesses a limit I at a given point A, then this limit is unique. It is always unique. Now, the limit is, if for example, I am considering Z square or anyone, we are substituting that one. If it is limit existable, then limit is acceptable. If it is limit does not exist, we are not considering limit does not existable. Then if it is limit existable, we can move the continuous. If continuous existable, we can move the differentiation. If it is not a limit existable, we cannot problem solving the continuous and differentiable or analytic. It is not a analytica, it is not a differentiable, it is not a continuous. Okay. The whole problem is depending upon the limit, then after continuous, then after differentiation. Now, first of all, we can check it using the definition of the limit prove that limit Z tends to 1 is Z square minus 1, Z minus 1 is equal to 2. We get the 2. Okay, what is the formula? Here f of Z equal to solution. Here f of Z equal to the given is Z square minus 1 by Z minus 1. What is the formula? Limit Z tends to 1 f of Z, that equal to limit Z tends to 1 f of Z means Z square minus 1 by Z minus 1. Then limit Z tends to 1, here Z square minus 1 means A square minus B square, A plus B into A minus B. Then Z plus 1 into Z minus 1 by Z minus 1. Now Z minus 1, Z minus get cancelled. Then limit Z tends to 1 is Z plus 1. Now substituting the Z value, that is 1. Now substituting that one, we get 1 plus 1, that equal to 2. Now answer we get. Then limit is existable. Then we can move maybe if it is asking the analytic this condition, we can move the next continuous process. Then after differentiation process. Now, if any problem they are given like this, we can solve this one. For example, we are considering limit Z tends to 2i, the f of Z is existable or not? Is limit existable or not? Limit existable or not? That means here f of Z equal to, they are given 2x plus iy whole square. Now limit Z tends to 2i, 2x plus iy whole square, that equal to 2x means a plus b whole square, that means a square, that is 4x square, plus iy whole square means I square, y square, plus 4xiy. Now limit Z tends to 2i. Here any Z is there here in this condition. Now we are substituting that. That means limit Z tends to Z means x plus iy. X plus iy it tends to 2i. Then it is 4x square minus y square plus I into 4xy. Now this is also written as limit x tends to 2i, 4x square minus y square plus I into 4xy. Next, another part is limit iy tends to 2i. That is 4x square minus y square plus I into 4xy. Now in this condition, I am substituting x tends to 2i. X tends to 2i. That is here to 4 into 2i. Overall 8, 4i, 2i whole square. 2i whole square means 4 minus 4. It is minus 16. Y is in terms of y square is constant. Y square minus plus 4 I into 4 y is constant. 2x means 2i overall 2i, that equal to, here it is minus 16, that equal to minus 16 minus y square I into I plus I square, that is minus 8y. This is the function. Now similarly limit y tends to 2i. Substituting that one, we get another condition. Here we are solving the z tends to z0 also. For example, the limit z tends to z0, the condition is f of z by z. They are given here f of z equal to, therefore f of z equal to, they are given z square. This is another condition, another problem. Therefore, limit z tends to z0, z square by z. Then we get cancelled both are. Then this is z0. Then this is z0. That means x0 plus I y0. This is the final solution. Okay. This is also limit existable. This is also limit existable. Okay. Now we are limit existable is condition is satisfied. Sometimes it is not existable also. Problems are there. For example, we consider in terms of that one is, let f of z equal to z square, z not equal to I, then 0 if z equal to I. The limit z tends to I, f of z equal to minus 1. But the limit is f of 0 equal to minus 1. Then therefore, but this limit is not equal to f of 0. Not equal to f of 0. Now that is the condition. This is not a limit existable condition. Limit not existable in this condition. Z tends to I, f of z equal to, that value equal to I square, that equal to minus 1. Is minus 1 is there in this condition? No. That's why it is not a limit, does not existable. Now some problems are there. Z power n equal to z0. We can solve that also. Z power n equal to limit z tends to z0. Limit z0 tends to power z0 power n is limit existable. So always, for example, it is x plus iy whole power n, that equal to x0 plus i0 iy0 power n. It is also limit existable. We can consider either any continuous, any constant k if it is existable. Okay. These are the problems of limits. Next we can move on continuous method. That is, if it is a continuous function, the limit continuous function means limit z tends to z0, f of z is equal to f of z0 is a continuous function definition. If it is existable, then it is continuous. Limit existable, continuous also existable, then we can move the differentiation method. Then that is also separate, that is f dash of x. That is f dash of x. If limit existable, next continuous is also existable, next differentiation is also existable, then we can move the analytic method. If analytic is we are considering in CR method. In CR method, it means they are using two methods, that is Cartesian form of the problem, Cartesian form of the coordinate, next polar coordinates. These are the next topics. We can see this total. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.